This semester in 6111, Jamele, Lockett, and I, Jonathan Abbott, worked on a classic game called Brick Breaker. Brick Breaker is a game in which there's bricks at the top of the screen that you want to break or make disappear.
So the camera is a standard NTSC output, and what we do then is to get the YCRC-B format and transform it into an RGB format. Then, to track the paddle better, we convert that to an HSV color space. And so the goal is to track the 3 different colors at the center of the paddle.
So we take the information from the paddle's location and tilt, and we produce the actual gameplay. The 3 things that you'll probably notice about the gameplay is that there's a paddle that rotates, a circular ball, and then all the bricks at the top. But I'm actually going to first talk about what's in the background. So the background has a really nice gradient that I'm very excited about, but it was actually very challenging to make because the memory in the hardware that we have available actually can't hold the whole image that we had pre-created. So we actually make the image at runtime to make a very nice background. So to talk about the 3 most important parts, we have the paddle, and what you do notice is that it does rotate. We use a rotation matrix to be able to rotate the paddle around its axis. Then the ball is circular, and to make a circle pattern we have to pipeline the information to get it to be a round circular ball as opposed to a rectangle. And then the bricks are all stored in an array on where they should be, what color they should be, and even their size, which we could change as part of some of the parameters. To make the game more exciting, we also added sound, so I'll let Jamele talk about the sound.
Right. So as Jonathan just mentioned, we have a background theme playing. So what we did was take a 16-second clip and then just loop it over repeatedly. Also, if you'll be able to hear, as the ball hits the bricks, there is a nice clicking sound. So to do that, we took samples from the Microsoft PowerPoint clip art, and we just converted it to a COE files in MATLAB, and then put that in the VRAMs of the FPGA.